Hi class, welcome. Today we're going to continue our discussion in Physics Chapter 3, 10th edition Kremkau transducers. Go ahead and open up to page 54. Earlier, you guys learned the word phasing or phase delay or automatic electronic. And we use this word to describe one of the three ways that transducers can be focused. We also know that focusing can be achieved with a curved lens or with a curved PZT. So now we're going to take that word again, that phasing word again, and we're going to learn about something else called steering. So not just focusing, but steering. We also learned that all transducers that are used for imaging have to be focused. Another thing that transducers have to, well, some transducers have to do is they have to be, let's see, 30, okay. So we learned that a curved lens, a curved PZT, or a curved phase delay pattern will be used to focus the transducer. All of imaging transducers have to be focused. If you have a really big transducer like this, when the pulses are coming out of the transducer, and of course there's a lot more than this, there's like hundreds of pulses. I'm just going to draw a couple. When they reach this tissue down here, they're covering like a big amount of tissue. But sometimes we have really small transducers that are just like this. If these pulses were coming out, this would not cover a sufficient amount of tissue. This is actually, how much ground is it covering? It's only actually covering like a small amount of tissue versus like a big transducer that would cover like more. So these small transducers, they need to be able, because they have a small footprint, they need to send their pulses in multiple directions in order to cover more anatomy. So for example, sometimes the pulses come out of the transducer like this, and they're kind of fanned out in various directions. So now, as you can see, it's covering, the pulses are going to be able to image a lot more cross-sectional anatomy, or like a lot more pieces of anatomy. So all imaging transducers are focused. Some, not all, can also be steered. And that just means sending the pulses in various directions. And when we do this, I want you guys to keep something in mind. Okay, so here are two transducers. Pulses can all be kind of sent out in different directions like this, or all the pulses can be actually sent out the exact same direction like this. Either way, because the pulses are traveling in a specific direction, that can be called scanning, sweeping, or steering. So on page 54 under arrays, I want you guys to highlight transducer must also send the pulses through many anatomic paths. This is called scanning, sweeping, or steering the beam. He's reminding us again that images are also called frames. And then he's going to give you guys a definition. So if you guys want to switch to your definitions color, presenting images in rapid sequential format. Sequential just means like in order. So presenting images in rapid order, similar to a movie or television, is called real-time sonography. So in the lab, when we're with each other and I say like scan live for me, or like scan in real time for me, and you're like sweeping your transducer across the patient, and we're looking at the picture moving, we're under the impression that the image is actually moving. However, what's actually happening, so what's actually happening is something like this. It's one picture, another picture, another picture. So it's like multiple pictures being shown at you really, really quickly. And so what you end up thinking you see is like a real-time scan, or like a live scan, or like a little movie, right? But really what the machine is doing, it's like taking frame, or like image, and then showing you the images really quickly. And our eyes are kind of tricked into thinking that like this is like we're somehow actually in real time live seeing into the body, but it's actually just a video. And it's just a bunch of frames shown to your eyes at a very quick rate. So it's similar to this guy here. So obviously we know that this little stick figure isn't actually like dancing or moving, but it looks like it's dancing and moving because it is, you know, one picture after another being shown to your eyes at a quick rate. And so that's what real-time sonography is. And then I want you guys to highlight the word automatic scanning, and then go down to where it says electronic scanning. So remember, automatic electronic is an AKA for phasing and for time delays. So I want you guys to also add phasing and time delays. Is performed with arrays. And then just in case we forgot what an array is, he's going to give us the definition. So if you guys want to highlight this in your definitions color, transducer arrays are transducer assemblies, or like transducers, with several transducer elements. Remember that those elements are going to be rectangular. So so again, all of our transducers have to be focused and some also have to be steered. So how does steering occur? Well, steering is also accomplished in 3 ways. So the 3 ways are, number 1, with a motor, and this is called mechanical transducers. So mechanical transducers, they have a little motor inside of them, and the motor rotates the PZT. And so this is done with a single element. There's only one PZT. So the motor turns this little PZT, and every time it turns the PZT, the PZT sends out a pulse. So it's kind of like those sprinklers. Let me show you guys really quick. So what you're seeing here is you're seeing this sprinkler. Obviously there's just one sprinkler on the floor, but it's able to water the entire lawn because inside of that sprinkler, there's an itty bitty tiny motor. And what it does is it like turns, and when it turns the location of the water that's coming out of the sprinkler. So like the water that's coming out is hitting different parts of the grass and able to cover like a lot of surface ground. And so that's the same with the transducers that have the motor. They have a little PZT crystal. And again, remember, this is a single element transducer. And so I often draw the picture like this because it helps me to remember it. So I'll draw a transducer like this with one PZT inside of it. And then I put this little arrow above. And what this helps me to remember is that this motor is going to rotate the PZT, and the PZT is going to send out a sound wave. It's going to rotate it a little bit more. It's going to send out another sound wave. It's going to rotate it a little bit more. It's going to send out another sound wave, and so on. So remember, we learned the word mechanical before, and we learned that sound is mechanical because what it does is it vibrates tissues in its path and it elevates tissue temperatures. But now when we're talking about transducers, so not sound, right? Not what sound does or why sound is mechanical, but what do transducers that are mechanical, what does that mean? I want you guys to link up the words mechanical motor, double M, mechanical motor. And that way, because sometimes they're called mechanical transducers, and they're just going to tell you like a mechanical transducer, you know, they're not going to tell you a mechanical transducer has a motor. And so you're the one that has to remember that a mechanical transducer has a motor. So I often say mechanical motor together, and that way that helps me to remember, oh yeah, there's that little itty bitty motor and it rotates the crystal, and every time it rotates that one crystal. And then remember, I also told you guys to draw that little picture with the one PZT, that one disc shaped PZT, and then that little arrow helps me to remember that the motor is turning that PZT. And so that's one way that pulses are kind of transmitted out in different directions. Our second one is sequencing. So sequencing is where the transducer applies voltages or electricity to small sequential groups. Sequential just means like to small groups in order. In succession means in order. So sequential groups means like one after another, and then succession means in order. And so I'll show you guys a picture that helps you guys understand this. And you guys also have a picture I'm going to reference to in the book. So here's an array transducer, and there is okay. So here's an array transducer, and there's like a bunch of PZTs in this. All these little blue rectangles are PZTs. What's going to happen is electricity will go to like these, like for example, like let's say that those are 5 PZTs. So electricity goes to all 5 of those at the same time, and it steers the beam in a specific direction. Then the next voltage comes, and it's going to send voltage or electricity to this next group, right? And that's what it means in succession. It does this in order from one end of the transducer to the other. So this is like the first set of voltages, this is the second set of voltages, and then it's going to do this one, and that's the third, and it's just going to keep doing this all the way down to the other end of the transducer. Notice that I'm always overlapping the groups, right? Like for example, like these 3 are used in group 1 and in group 2. Notice I always have like that overlap, like here's an overlap, here's an overlap, and here's an overlap. And the reason that's important to remember is that sequencing has a benefit, and what the benefit is that it will create very detailed images because it sends out so many pulses. So that's one of the questions that they're going to ask you on the SPI is like, out of mechanical transducers or sequencing transducer or phasing transducers, which one is going to be more detailed? The answer is sequencing.